Greetings. My name is Eric Rekstead. I'm at the University of St. Andrews, and this is a continuation of the distance sampling online workshop that we've been developing. This section is describing an alternative means by which you can analyze distance sampling data. The rest of the workshop has been describing the use of the software Distance for Windows. So in this brief section, we'll show you another way to analyze distance sampling data using the R programming language. Now, of course, nothing changes with regard to survey analysis or field methods when you analyze distance sampling data using R. So we'll focus exclusively upon the analysis of distance sampling data. To make the most of this, we've structured this section of the workshop primarily using exercises. And so this lecture is going to simply be a short overview of some of the differences that you will face when you choose to analyze distance sampling data using R. Now, if you've used Distance for Windows, you'll realize that the instructions on how to perform your analysis were passed to the computer through quite an elaborate series of menus and mouse clicks and pull-down menus. That worked very well, and you've seen how to do that in the previous portions of these online materials. However, most of the analyses that we've shown you can also be done using the R software. What you need to be cognizant of is that to describe the analyses that you wish to do to your distance sampling data using R, you'll have to type a series of commands, or what we call scripts. And you'll be typing in those scripts using either the R console, or in the demonstrations that we'll show you in this workshop, you'll be using the RStudio interface. However, before you can do a job of analysis of distance sampling data using R, you'll need these three elements. The first element is, of course, the R software and some convenient means of interfacing with that R software, namely RStudio. The materials that we've prepared here don't describe in detail how you go about installing R or RStudio. There are many places online where you can learn that for yourself. And we'll assume that you already have R and RStudio loaded onto your computer. However, in addition to those basic fundamentals, you will also need what is called a package in the R terminology, and this particular package that you'll need is, unsurprisingly, the distance package. And so you'll need to go to the CRAN website to download that R package and the packages upon which it depends. Installing R packages is also a fairly straightforward exercise, and we'll not describe it in detail here. Its third aspect that I'll dwell upon for another minute or two. You'll need to have a deeper understanding of the organization of distance sampling survey data. Think about the data that you've collected from your distance sampling survey as if you were going to place it into a database. In that context, that database would have a hierarchy. In other words, you can think about your study as consisting of the entire study area and attributes about the study area, and we'll call that, and that information resides in the global layer. At the next layer below that in the hierarchy, you may have broken your study area into geographic subregions or strata, and there will be attributes or information about those strata that you may record. Further down the hierarchy is then the samplers or the transects that you place in all of your strata. There are attributes associated with each of those samples or transects. And finally, belonging to each transect are one or more, or zero or more, detections of objects. And there are characteristics associated with those objects that are recorded at that level of the database. When you use distance for windows, those strata or those data layers were made obvious to you in the Windows interface. You had the leftmost set of information was recorded about the study area in the global layer. Then there was information in this region layer about the strata, information or attributes about each transect was recorded in the sample layer, and finally, information about the detections were recorded in the observation layer. And that was all transparent and easy for you to understand when you were using the distance for windows interface. Now that you're no longer using the distance for windows interface, you need to organize the data yourself. Now, if you looked at the data import video that was in Chapter 6 of these online materials, Professor Thomas described in some detail how to go about organizing data in data files so that they could be imported into distance for windows. When you use the R package distance, you'll likewise need to organize your data in terms of files that can be read by the R software for subsequent analysis by the package distance. This particular slide shows identical data as stored in distance for windows and as stored in a basic text file, or what we'll be calling a flat file, for analysis in R. These data happen to be the data for the first exercise that you're going to do shortly, working with duck nest data. So spend some time staring at this slide and noticing the similarities between how the data are recorded in distance for windows and how those same data need to be recorded in your comma-separated values file, or CSV file, that you'll read into R. As I say, most of the information that you'll derive from how to use R to analyze your distance sampling data will come as a result of hands-on exercises. This is the only lecture associated with this chapter in the online materials. So it's now time to turn your attention to these exercises, and we've given you 4 exercises to explore some areas of the capability that the R software has for analysis of distance sampling data. The first exercise, and the data I've showed you briefly on the previous slide, are of duck nests in the high elevation country of southern Colorado in the United States. It's an example of a conventional distance sampling analysis. We showed you this data and how to analyze it in distance for windows in Chapter 1 of this workshop. So you may go back and review the materials in Chapter 1 before attempting to analyze these data. The second exercise. And again, it's merely coincidence that all of these data sets, all of these exercises, happen to be avian related. The second exercise deals with some Hawaiian songbird data. Those songbird data were collected in point transects. The purpose of this exercise is to show you how to incorporate covariates into a distance sampling analysis that you do in R. Again, this exercise, or this data set, was analyzed using distance for windows in Chapter 5 of these online materials. So again, go back and forth between the description of the analysis in Chapter 5 using distance for windows and this particular exercise in this chapter. Third analysis works with a data set collected here in Scotland on a bird species called crossbills. It's a very different kind of analysis, and in fact, this is an analysis that you cannot perform using distance for windows. As the exercise will describe in some detail, the study consists of two surveys. One survey is used for the purposes of deriving a detection function, using a series of lures or calls to try to get these crossbills to respond to field investigators. And a second survey, called the main survey, is then conducted to collect data for the purpose of trying to estimate the size of this crossbill population. Because we actually have two distinct analyses being conducted, but we're blending those two analyses to produce our overall estimate of crossbill abundance, it's fairly challenging to try to properly measure the uncertainty or associated with that survey. And so there's an extended component of this third exercise associated with trying to properly measure the uncertainty in that population estimate. The fourth exercise that we have prepared for you at the moment is, again, another songbird survey. It's a multi-species survey now. It's called the Montrave study. It's described extensively in the book on distance sampling by Buckland et al., published in 2015. The reason we've included this analysis for you is not because there's anything particularly unique about the analysis itself, but what is unique is that you have to deal with some data management problems when doing a multi-species survey. You'll want to filter the data on a species-specific basis to be able to produce the species-specific abundance or density estimates. In distance for windows, the data filtering capability was very easy for you to navigate because there's a built-in feature for doing that in distance for windows. When using the R software, you are left somewhat to your own devices to be able to do proper data management and proper data filtering. Now, it's not challenging to filter data in R to subset or select specific records out of a data file. The challenging part is to make sure that the sampling effort is respected from the study design. And this fourth exercise talks you through the methods associated with trying to make sure that you don't miss out on some sampling effort when you're doing your data filtering. The final aspect of the fourth exercise is we've taken the opportunity to write some functions that you might want to use when analyzing data such as this that arise from a multi-species survey. If you have multiple species, you might want to repeatedly analyze these data, subsetting on one species after another after another. That exercise can be tedious and could be prone to error, and so it lends itself to developing some of your R skills and writing some code that you can reuse and thereby modularize your analyses to make it both more efficient and hopefully less prone to error. So we hope these exercises and this lecture have guided you on your way to performing distance sampling analyses using the R package distance.